Hello everyone, hope you are fine and doing well. Last session we explained the height and median. Today we will talk about the perpendicular bisector of a triangle. So let's start. Perpendicular. Any two lines that make a 90-degree angle are called perpendicular. For example, this segment AB. To draw a perpendicular to segment AB, just put the set square like that and draw a line. So this line is perpendicular to AB. Another one, this one is also perpendicular. They makes a 90-degree angle or a right angle, so they are perpendicular. We can draw infinite number of perpendicular lines to AB. Okay, all of these are perpendicular. What about bisector? Bisector means any line that cut the segment AB into two equal parts. Look at the segment AB. Its length is 8 centimeters. So its midpoint will be 8 divided by 2 equal to 4 centimeters here. So any line that passes through this midpoint is called the bisector of the segment AB. For example, let's draw some bisector. This one is the bisector of the segment AB because it passes through the midpoint. This one also is a bisector. This one is also a bisector. All of these are bisectors because they passes through the midpoint of the segment AB. What about perpendicular bisector? So simply the perpendicular bisector is any line that's perpendicular to the segment AB and passes also through its midpoint. So to draw the perpendicular bisector of AB, locate its midpoint. So here it is 8 centimeter. Its midpoint is 4. Then draw a here. Then draw a perpendicular to AB through this point like that. So this line is the perpendicular bisector of the segment AB. It's perpendicular because it makes a 90-degree angle and bisector because it passes through the midpoint of AB. So the perpendicular bisector of AB is a line perpendicular to AB through its midpoint. Steps to construct the bisector of AB. We have two methods, either using a set square or using a compass. Let's use the set square to draw the perpendicular bisector. So first we will locate the midpoint. So AB is equal to 10.8. So its midpoint will be 5.4. So here is 5.4. So here is the midpoint. We will draw through this midpoint a perpendicular like that. Okay, like that. So this line is the perpendicular bisector of AB. It cut it into two equal parts. This one is equal to this part. Let's take a look on the second method using a compass. So we'll bring a compass here. Now we will open the compass more than half of the distance between A and B. So first put the compass on the point A, then make it a bit wider, not like that, for example. Then we will draw two arcs. So this is the first arc. Then we will put the compass on the point B and we will draw another arc. We got two intersection points, just connect them like that. So this line is the perpendicular bisector of the segment AB. Okay. Okay. Now we will erase the arcs. Sorry. Okay. Circumscribed circle of a triangle. Now let's look at this triangle XYZ. Any triangle, as you know, has 3 segments or 3 sides, so they should have 3 perpendicular bisector as well. So let's try to construct them using the 2 methods. So first we will try to construct them using a set square. So first locate the midpoint of each segment. We will start by the segment YZ. So YZ is equal to approximately 12 centimeter. So its midpoint will be 6 centimeter here. So here is the midpoint. Then through this midpoint we will draw a perpendicular like that. Okay, like that. So this is the perpendicular bisector of the segment YZ. Okay, now for the segment XY, the same thing. Locate the midpoint. So here is XY. XY is equal to approximately 7.5. So its midpoint will be 3.75. So here, then draw a perpendicular through this midpoint. Okay, like that. The third perpendicular bisector of the segment XZ. So locate the midpoint. So XZ is equal to 11.5. So its midpoint will be 5.7 here. Then draw a perpendicular using a set square. Okay. So okay. Note that the 3 perpendicular bisector meet in one and only one point. So they are concurrent. They are concurrent because they meet in only one single point. This point is called the circumcenter of triangle XYZ. So suppose that this point is O. So O is the circumcenter. I'll write it here. XYZ. Okay. Now we will try to draw a circle using the compass. So we will put the compass on the point circumcenter O, and the radius will be OZ, like that. Excuse me, I am facing some difficulties because I am drawing with the mouse, like that. So we will draw a circle of center O, which is the circumcenter, and radius OZ. Let's erase that. Okay, so this circle is the circumscribed circle of triangle XYZ. It has a center O and radius OZ, and it should passes through the vertices of the triangle XYZ. As you notice here, it passed through X, through Y, and through Z. Okay, let's answer some questions. Can we say that perpendicular bisectors are concurrent? Justify. Yes, all the perpendicular bisectors are concurrent because they meet in one and only one point. So as you notice here, they meet in one point, so they are concurrent. What do we call the intersection of perpendicular bisector? Circumcenter. Okay. Now we will try to draw another circumscribed circle of another triangle using the second method, which is using a compass. So we will draw the perpendicular bisector of each segment. Okay, so we'll draw the first arc on O, then the second arc on P, join these two intersection points. So this line is the perpendicular bisector of the segment OP. Okay, now we will erase the arcs. Okay, another line. This one is equal to this one. Then the perpendicular bisector of OA, so put the compass on OA, make it a bit bigger. Now this is the first arc, then the second arc, here it is. Join these two points, this one and this one. I will extend these two intersection lines so that they meet, and I can find the circumcenter. Now we will erase the arcs. Okay. Then the perpendicular bisector of the segment AP, the same steps, put it on P, make it a bit bigger, draw the first arc, then put it on A, and draw the second arc. So we will connect these 2 points here. As you notice, the 3 perpendicular bisector intersect in one point, so they are concurrent, as we explained before. If they does not meet in one point, we have something wrong. So this one, and this one. Suppose that this point is L. Okay, so L is the circumcenter of triangle AOP. Now we will draw the circumscribed circle. Just put the compass on the circumcenter, and radius will be LA or LP. Okay, so the second point on P, for example, exactly. And as we explained, the circle should meet all the vertices of the triangle. Okay, let's answer some questions. The circumscribed circle should pass through the vertices of the triangle. Yes, it's true. The circumcenter lies always inside the triangle. If you look here, the circumcenter is outside the triangle. In the previous triangle, it is inside. So that depends on the nature of triangle, if it is acute, obtuse, or right. We'll talk about that later. So not always the circumcenter lies inside the triangle.